Hello and welcome to helpyourmath.com. In this video, we are going to look at all the transformations of sine and cosine functions. So sit down, buckle in, get some graph paper, let's get started. First, let's review a few things. Let's talk about the parent functions of our sine and cosine families. So we have f of x is equal to sine x, f of x is equal to cosine x. For either function, the domain is all real numbers, right? I can plug in any value I want and get a sine value or a cosine value of a number. The range is -1 to 1, right? So no matter what I plug in, any number in the world is going to be a number between -1 and 1. The amplitude of our graphs is 1 because that would be going from the maximum to the midline or the minimum to the midline, and that's going to be a distance of 1. The period for our parent functions will be 2 pi, and we'll have 5 key points. When I talk about the key points, I am talking about any point that is on the midline, any maximum point, or any minimum point. Everything else is just kind of in the middle, in the flow of things. To figure out the 5 key points, what we do is we take the period and we divide it by 4. And what that's going to do is that's going to tell us the increments of those 5 key points. We start with the parent function, we're going to start at x equals 0, and then we add those increments as we go. So if we start at x equals 0, that would tell us our first key point. The next one is going to be the period, which in this case is, well, let me go up here. So we have x equals 0. Okay, then the next increment we want is going to be the period 2 pi divided by 4, which is equal to pi over 2. We add that on to the previous x value. So the next one would be 0 plus pi over 2, which is pi over 2. The next important key point is going to be pi over 2 plus pi over 2, which is pi. So we can see here the buildup of those 5 key points. So we start at 0, 0 for the sine, 0, 1 for cosine, and then we add the increment, which I determined to be pi over 2. So 0 plus pi over 2 gives me pi over 2, plus pi over 2 is pi, pi plus pi over 2 gives me 3 pi over 2, and pi over 2 plus 3 pi over 2 gives me 2 pi. Notice that the y-coordinate when we start and end a cosine or sine graph, it's the same y-coordinate in the first important key point of a period and the last key point of a period. One more thing is, how do we use the information given to us in the equation to help us with the graph? So the coefficient of the entire thing is going to tell us the amplitude. That tells us the height between the midline and the maximum, or the midline and the minimum. Also, it tells us the direction of this. So if A is positive, then it would go to a maximum first. For sine, that means it starts in the middle, goes up first. For cosine, that means it starts at the top. If A is negative, then it goes to a minimum first. For sine, that means it's going to start in the middle and go down. For cosine, that means it starts at the bottom. We want to figure out the period based on the value of b that's given within the function itself. So the period is going to be 2 pi divided by b. That tells us the length from start to finish of one cycle. We also have the idea of a phase shift. This would be the new x-coordinate. This is the horizontal shift of the graph, which would be c over b. So we've talked about this before, where it's, taking that what's inside the function and setting it equal to 0, because we know sine of 0 is 0. We know cosine of 0 is 1. That helps us figure out the other points along the way. If you solve for x here, you'll end up with c over b. The x-coordinates of one full period. So if there is a horizontal shift, and even if there's not, it's good to know the x-coordinates. The x-coordinates are going to range from that initial c over b to that starting point plus one full period, right? This is one full period. So this would tell us the starting point, the starting x value, and the ending x value. Also, the graph will shift up or down d units. The midline of the graph is located at y equals d. A sine graph will have one period begin at c over b, again that's that phase shift, comma d. And cosine's a little bit trickier. The cosine will start at c over b, also that same phase shift, but then it begins at d plus a. So we have to keep that in mind, where notice that's the lowercase a. That's the one that was given in that coefficient that was given. Okay, let's get right to it. We want to sketch a graph of f of x equals -2 times cosine of 3x minus 1. The amplitude, well, first let's define our variables. So we have A is -2, B is +3, C is 0, and D is -1. How do I know that D is -1 and that's not that C is +1? Because if we wanted there to be some sort of horizontal shift, we would have to put the 3x - 1 inside parentheses. Since it's not in parentheses, the only thing that's within that cosine function is 3x. Okay, the amplitude of this will be the absolute value of A, so it's going to be the absolute value of -2, which is +2. What does that negative tell us about this graph? It tells us that we're going to be starting at the bottom first, and that should be verified when we look at filling in our table. The period, so to figure out the period, that is 2 pi divided by b. b is 3, so we're going to have 2 pi divided by 3. So one full period will be 2 pi over 3 units. That's going to be the distance from the first point of a period to its last point. The phase shift, since c is 0, 0 over 3, there is no phase shift. And the equation of the midline, that's going to be determined, this is y equals d, and d is -1. Okay, so now we want to figure out our 5 key points. So we're going to have x and f of x. To figure out the 5 key points, the first one we're going to look at is going to be c over b, comma, d plus a. So c over b is 0, so we're going to have x is 0. D plus a will be -1 plus -2 down at -3. So -3 should be the lowest point of this graph. Okay, to figure out the next key point, so we're starting at the bottom, we want to go to the midline. That should be our y coordinate, but what is the x coordinate? So to figure that out, we're going to take the period and divide it by 4. Period divided by 4, that's 2 pi over 3 divided by 4. We have a nice complex fraction here. We have 2 pi over 3 divided by 4 over 1. This is 2 pi over 3 times 1 over 4. Before I multiply, I'm going to simplify as much as I can. Okay, so we end up with pi over 6. So we know that the x's are going to be going in units of pi over 6. So I'm going to take my initial 0x, which is 0, and add pi over 6 to it. That's going to tell me the next important point, and this should be where the midline is. And if we want to verify we can, we don't have to. We can kind of like trust our work that this is right. We should be at the midline, so this should be at -1. And again, if you're ever not sure of anything, if this is like, whoa, what is she doing? Plug in and check it out and see what happens here. Okay, so now what we're going to do is we're going to take pi over 6. We're going to add it to pi over 6 to figure out the next x coordinate. X pi over 6 plus pi over 6. This is 2 pi over 6, which is the same as pi over 3. So here we have pi over 3. What's happening here? Well, we're going up 2 units again, right? The amplitude was 2. We're going to go up 2 units. That's going to put us at +1. So here's that midline. Now we're going up 2 units. That's what the amplitude tells us is the change in the y's from the midline to the maximum. Now we start going back down. We're at the max. Now we go back down. We're going to take this x. We have pi over 3 plus the increments pi over 6. I need a common denominator. The common denominator between 3 and 6 is 6. I'm going to multiply this guy by 2 over 2 to get that denominator of 6. Now I have 2 pi plus pi is 3 pi over that common denominator. 3 pi over 6 is equivalent to pi over 2, so I'm going to write pi over 2. We're going back to the midline, so we're going back down to -1. And last but not least, let's see, we have pi over 2, and we're adding to that the increments pi over 6. In order to add these, I need to find a common denominator. That would be 6, so I'm going to multiply by 3 over 3. I also could just use this. Yeah, that was the unsimplified form. This probably would have made my life easier, but that's okay. We get back there. Now we have 3 pi over 6 plus pi over 6. That gives me 4 pi over 6, which simplifies to 2 pi over 3. That's kind of a weird number, but how do I know that I'm right? Well, because it matches the period and there was no phase shift. So I feel pretty good that that 2 pi over 3 is what it should be. And we should be going back to the beginning at -3. Again, if you want to fact check any of this by plugging into your cosine function, absolutely check it out. This should work. We really hope it does. Otherwise, we're in big trouble here, aren't we? Okay, and now we're ready to graph. So when we graph, I'm going to start with the midline y equals -1. And now I'm going to look at my points. I have 0, -3, which is what I should have, right? I'm starting 2 units below because the amplitude was 2 and it was negative, so we're starting down. Then, let's label this. Sure. Okay, I'm going to go by the increments pi over 6's, but I'm only going to write every other one. So here's 1 pi over 6. This is going to be 2 pi over 6, which is pi over 3. 3 pi over 6. This is 4 pi over 6, which is 2 pi over 3, excuse me. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6. 10 pi over 6 will be 5 pi over 3. And then we have 11 pi over 6 and 12 pi over 6 is 2 pi. So I'm just going to fill that in. It does say to include 2 full periods. We found the key points of 1 period, but we're going to use that information to help us with the second period without creating a table of values. So we're starting down at -3. We go over to pi over 6 and -1, excuse me, -1. We go to pi over 3, we go up to 1, that's our top. Pi over 2, we go back to -1. 2 pi over 3, we go back to the bottom at -3. Then next, we're just going to repeat this pattern. So we went bottom, middle, top, middle, bottom. We're starting at the bottom. We go to the mid. We go to the top. We go back to the mid. We go to the bottom. I'm ending at 4 pi over 3, which would be that second period, right? Because 4 pi over 3 minus 2 pi over 3 is 2 pi over 3, which is the length of 1 period. When we connect these, we do a nice, smooth curve. Do not turn this into a little zigzag pattern. Smooth curve. So it's curve, gorgeous. Whoops, I missed a point though. And there are 2 full periods of this cosine graph. I know it can be a little intimidating. I hope this makes sense. We're going to do another example, or actually quite a few, so that hopefully this will start to click. How about this one? We have f of x is equal to 2 times sine of x over 3 plus 4. Let's label A, B, C, and D. In this case, we have A is equal to 2, B is equal to 1/3, C is equal to 0, that means no phase shift, and D is equal to 4. Okay, let's label everything. So the amplitude, that's the absolute value of 2, which is 2. The period will be 2 pi over b, so 2 pi over 1 over 3. This is going to be 2 pi over 1 divided by 1/3, which is 2 pi over 1 times 3 over 1. Oh, everything in the denominator is 1s. Okay, this one's a little bit nicer. This is going to be 6 pi. We can drop the 1 because 6 pi divided by 1 is 6 pi. So this period will be 6 pi. The phase shift, since C is 0, there is no phase shift. Yay! The equation of the midline is y equals d, so this will be y equals 4. How you doing so far? So far, so good? Well, you just answered a computer, so I'm a little worried about you. Just kidding. Let's go. Let's keep going. We can do this. Okay, so next we want to figure out our 5 key points. We're going to start with that first. Remember, the first one for sine is going to be the phase shift, C over B, comma, D. C over B is 0, and D is 4. Okay, lovely. Now what? We need to figure out the increments for x's. So to figure out the increments for x's, remember what we do? We take the period and we divide it by 4. That tells us where we're going to find our key points. So we're going to take the period divided by 4. That's 6 pi divided by 4, which is 3 pi over 2. So we're going to count by 3 pi over 2's. What I find helpful, because there's kind of like a pattern with the x's and then a pattern for the f of x's or the y's, is I'm going to just fill in all the x values first. I'm just going to keep adding 3 pi over 2 to the previous x value. So 0 plus 3 pi over 2 is 3 pi over 2. Now 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. Well, 6 pi over 2 is the same as 3 pi. So this will be 3 pi. When I figure out the next one, I'm going to use the unsimplified version since I know my increments have a denominator of 2. That way I'm not like redoing work that I just undid. So 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. And last but not least, 9 pi over 2 plus 3 pi over 2, that's 12 pi over 2, and 12 pi over 2 is 6 pi. Do I feel pretty good about that ending x result? I do, because that was the period. There was no phase shift, so yeah, the period should match that last point of this cycle. Okay, what are we going to do for these y values now? We're using the fact that this is a sine graph. This sine graph starts in the middle. A is positive, so it's going to go from the middle to the top. The top is going to be 2 larger than the middle, so it's going to be 4 plus 2, and that's going to give me 6. Next, we go back to the midline, so every other point here should have a 4 as its y-coordinate. Now we're going to go to the minimum point. So the next key point will be the minimum. That's going to be 2 fewer than 4, which is 2. Go back to the middle at 4. And now we're ready to graph this, except my graph only goes up to 4, but that's okay. We'll make do. So we have the midline here at 4. We're going to start at 0, 1, 2, 3, 4, 0, 4. We're going to go, I need to label my axes, don't I? So we have 1, 2. I didn't label the y-axis last time, and usually, that's not important because we're not doing anything weird. We're just using the counting numbers or the integers. For the x-coordinates, let's see, I'll just use the x-coordinates that I have here. So I'm going to do 0. This will be 3 pi over 2. This one's going to be 3 pi. 9 pi over 2. This will be 6 pi. This one will be 15 pi over 2. Then this is going to be 9 pi. This one will be 21 pi over 2. And this will be 12 pi. Okay, so we have that labeled. We want to make sure that we're using equally spaced increments, right? Because they're supposed to represent the same amount when they're the same distance apart. Now we're going to 3 pi over 2 and up 5, 6. We're going back to the middle. Don't forget to stop at the midpoint, at the midline. Then we have 9 pi over 2, 2 down here. 6 pi goes back to the middle. And then 6 pi ends the first period that we're looking at, and it's going to start the second period. So it starts there. Then here we're going to go back up to 6. At 9 pi, we're going to go back down to 4, all the way down here at 15 pi over 2, and then back up to, or 21 pi over 2, excuse me, and then back to 4 for 12 pi. Nice smooth curve. So we're going to go like this for our sine graph. And there's 2 full periods of the sine graph. Okay, so now we're going to buckle in and we're going to look at some that have phase shifts. So let's get to it. Let's first label our A, B, C, and D. A in this case is a half. And B is equal to 2. And C, we do have a C, and it's pi over 6. Notice that just like kind of with other functions, when we have that minus, that indicates a positive C value. Oh, and let's not forget D. There is no D. D is 0. The amplitude is the absolute value of A, so it's going to be 1/2. The period, remember how we figure out period? It's 2 pi divided by B. So in this case, it's going to be 2 pi divided by 2, which is pi. So the period will be pi, 1 pi. Cute. The phase shift, to calculate the phase shift, that's C over B. That will be pi over 6 over 2. Oh, sorry, equation of midline. This will be pi over 6 divided by 2 over 1. We can multiply by the reciprocal. Pi over 6 times 1/2. And we end up with pi over 12. So our phase shift is pi over 12. Ew, gross. Let's try that again. Pi over 12. The equation of the midline will be y equals 0. Okay, so that's nice. We get a break there. We don't get a break with the phase shift though. And now let's identify our 5 key points of this cosine graph. So we have x and f of x. Remember, the first important point for our cosine graph is going to be c over b, comma, d plus a. So c over b is pi over 12. That was the phase shift, so we're starting at pi over 12. And d plus a is 0 plus 1/2. So we're going to be starting at the tippy top at 1/2. Now let's figure out the increments that we want to use. And things are going to get really fractiony here, so brace yourself. Remember how we figure out increments? We take the period and we divide it by 4. So the period was pi. Okay, so the increments aren't bad. They're pi over 4. But to figure out the second x-coordinate, we need to add pi over 4 to the first one, which was pi over 12. So to figure out our second x, we're going to do pi over 4 plus pi over 12. To be able to add these, I need a common denominator, which in this case will be 12. I'm going to multiply this guy by 3 over 3 to give me that 12. Now I have 3 pi over 12 plus pi over 12. That will be 4 pi over 12, which is pi over 3. I'm going to complete the x's like I did in that last example because, we're going to get on a roll here. I don't want to break it up by doing the y values at the same time. Okay, the next x coordinate that we're interested in, so this is a cosine. So this is the top, this is the middle. Now we're looking at the bottom of the graph. It's going to be pi over 3 plus pi over 4. And we can use pi over 3 or we can use our unsimplified thing here. Since it looks like the common denominator is going to be 12 anyway, I'm going to go ahead and just use that. Save myself one itty bitty step. So we have 4 pi over 12 plus pi over 4. And what's going to be important here is that pi over 4 is the same as 3 pi over 12, right? Because I need that common denominator. So I'm just going to kind of go ahead and do that now. This gives me 7 pi over 12. Can't simplify it, so we'll just leave it like that. What's the next key x coordinate? Well, it's going to be 7 pi over 12 plus pi over 4. So 7 pi over 12, the previous key x coordinate, plus the increment pi over 4. Pi over 4, remember what we're going to use instead because we want that common denominator, 3 pi over 12. 7 plus 3 is 10, so we get 10 pi over 12, which simplifies to 5 pi over 6. Okay, one more. We have 5 pi over 6. I'm going to use that unsimplified 10 pi over 12 plus pi over 4, which remember what I'm writing it as, 3 pi over 12. That gives me 13 pi over 12. Now, one thing I mentioned at the very beginning of this video is that the x coordinates for one period are c over b, which is the phase shift, and then c over b plus the period. So c over b is pi over 12 plus the period, which is pi. Well, pi is 12 pi over 12. So this should match that very last x coordinate, and it does. So I feel pretty good about that we have the right x values here. It ended up as it should have. Now let's talk about the y's. So the y is starting at the top. We're going to go back down to the middle. The middle is, in this case, 0. So we're making a stop in 0. We're going to go down to the bottom. So we're going to do 0 minus the amplitude, which would be -1/2. We go back to 0. We go back to the top. Okay, so when we do this graph, now I'm going to kind of cheat here. Don't tell anyone. And I'm going to say that this is 1 and this is -1. That way I don't have to do anything weird with this and I don't have to like squish it all in because I can just use that 1/2 that's in between 0 and 1. For the increments of the x-axis, I think I want to count by 12ths. Now, one thing that, because I know this stuff is hard, so one thing I'm not particular about is when you're labeling your graph, if you don't want to simplify the pi over 12s, that's fine. There are a lot of them that end up being simplified and it can get really, really confusing. So we're just going to count by 12ths and I'm going to leave them unsimplified and I'm going to be okay with that. Here we have 0 pi over 12. Here's pi over 12. This will be 2 pi over 12. I don't know why I'm simplifying it in my head, but I am wanting to write a 6. Okay, we're going to leave it as 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 11 pi over 12, 12 pi over 12, which is just pi, and so on. Now this does say to include 2 full periods, but just because the increments, the phase shift was so tiny and the increments are a little bit bigger than that, we're just going to do 1 period. So sorry, just including 1 full period. And we'll just do those key points that I listed below. Okay, so we're starting our graph this time at pi over 12. We're not starting at 0. Pi over 12, 1/2. We're going over to pi over 3. Where's pi over 3? Pi over 3 was 4 pi over 12. And we're going to 0. Then we're going to 7 pi over 12, which will be right here, going down to a -1/2. Going to 5 pi over 6, which is 10 pi over 12, going back to 0. And I actually don't have room on the graph. It's going to be like right here, my 13 pi over 12. So this one's really stretched out, isn't it? Whoa, stretch. And that would be 1 full period of this cosine function. Let's do one more example. It's a sine graph, so at least there's no trick at the beginning like there is with cosine. Let's see what we have here. I'm going to determine A, B, C, and D. It looks like we have all of them this time. A is -3. B is 1/2. C is -π/6. And D is -1. Okay, the amplitude is the absolute value of A, so the absolute value of A is 3. The period is 2π/b. This would be 2π divided by 1/2. There's my daughter crying in the background. Sorry about that. 2π/1 divided by 1/2. That's equivalent to 2π times 2. So our period, oh, that's nice. We have a nice integer period, well, integer times irrational of 4π. The phase shift, this is C/B, and I'm totally running out of space here, so let's see. C/B is -π/6 over 1/2, very complex fraction here. This will be -π/6 divided by 1/2. That's -π/6 times 2/1. This will be -π/3. Okay, so the phase shift is -π/3. Uh-oh, my graph doesn't have negatives. We're going to have to include them. And the equation of the midline, that's y equals d, y equals -1. Okay, so to figure out the important points of this graph, the 5 key points of this one period, we're going to look at C/B to start, and D is the y coordinate. So C/B is -π/3, and y is -1. To fill in the rest of the x's, remember what our increments are. We're going to take the period and divide it by 4. So the period divided by 4 will be 4π divided by 4. Oh, that's nice. Okay, so they're increments of pi's. Unfortunately, we don't have a nice thing here. We have -π/3. That's okay. We can work with that. So to figure out the next key point of this period, we're going to take -π/3, and we're going to add it to pi. One thing we're going to want to keep in mind here is that pi is the same as 3π/3. Why is that important? Because it looks like we're going to have denominators of 3's. So now we have 3π/3. This is -1π plus 3π is +2π/3. So the next one will be 2π/3. To figure out the next x coordinate, I'm going to work down here now. We have 2π/3, and we want to add to that the increment of pi, but again, because we want that common denominator, pi is the same as 3π/3, so I'm just going to keep using that. 2π plus 3π is 5π/3. Okay, now we have 5π/3. We're going to add to that pi, but really we're going to think of it as 3π/3, and this will be 8π/3. And lastly, we're going to take 8π/3 and add pi to it, which is 3π/3. That gives us 11π/3. And so those are the 5 x coordinates of our key points. How about the y coordinates? So the y coordinates, we're going to use the fact that the middle is -1 and the amplitude is -3. Or sorry, the amplitude is 3, but the fact that A is negative means this sine graph is going to go down first. It's going down 3 units. So it's going from -1 down 3 units down to -4. It's going to go back to the middle. Now it's going to go to its peak at -1 plus 3, which is 2. And it's going to go back to its midline at -1. Now we have the key points for one period. Let's set up the graph. I'm going to draw my midline at -1. I'm going to use increments of π/3's. So I have that -π/3 right here. 0, this is 1π/3, 2π/3, 3π/3, 4π/3, 5π/3. This will be 6π/3. I'm not worrying about simplifying. I think I mentioned that before. This will be 8π/3, 9, 10π/3, 11, 12π/3. And let's see. I think, again, we're going to do just one period. So, sorry. Okay, so -π/3, -1 is going to be right here. 2π/3 is here, down to -4 will be right here. 5π/3 back to the middle at -1. 8π/3 up to the top at 2. 11π/3 back to -1. And this is going to be a nice smooth curve. It's a little bit stretched out again. And there it is. We made it. These have been examples of graphing sine and cosine functions when we've had all the transformations. Thank you for stopping by.